All right, so this is a review for writing the formula and writing the name for ionic compounds. And I've mixed together ionic compounds with metals whose charges we know, with metals of charges we don't know, and then I've also included polyatomic ions. Okay, so we're just going to run through these. The first one gives you KOH. Okay, so I'm going to write the name of this. I have potassium, and OH is hydroxide. Okay. Before I finish, I need to make sure I don't need to write the charge of potassium as a Roman numeral behind potassium. And so I look at the periodic table. Potassium is a group 1 metal, so its charge will always be 1+, so I don't need to include the Roman numeral in this name. Okay. For the next problem, iron 2 nitrate. Okay. Iron, I'm being told, has a 2+ charge. Nitrate is NO3 and its charge is 1-. That's one of your polyatomic ions on your table. So when I cross my charges, okay, I'm going to have Fe, and I'm going to have just one iron, but I don't need to put that as a Roman numeral. And then I'm going to have 2 nitrates. So remember, I need to put nitrate in parentheses because I have more than one polyatomic ion. Okay, for the next one, cobalt and phosphate. So I've got cobalt as my metal. Phosphate is my polyatomic ion. Okay. Look at your periodic table, and what you'll notice is cobalt is one of your transition metals, so I do not know its charge. I need to include that in the name. So let's figure it out. This one's going to be a little bit of a trickier one. Okay, so phosphate has a 3- charge, and I have 2 of them, which means phosphate overall contributes 6-, which tells me that cobalt overall is going to have to contribute a 6+ charge, so that your overall charge of your ionic compound is 0. Well, here's the problem. I have 3 cobalts. So if I have 3 cobalts, each of them, so if I divide by 3, each of them needs to contribute a charge of +2. And so the charge of cobalt needs to be 2. Okay, that's probably one of the trickier of these examples. So go back, feel free to go back and rewatch that explanation. The one thing that people can fall into the trick of, they say, oh, well, the charge of phosphate was 3. The charge of cobalt was 2. Ms. Polliner, why don't you just do that? I created this wonderful trick. It works most of the time, but there are times that it won't work, and you'll see later on in this. So I would much rather you learn it the way that I just explained it. Okay, so I'll show you when it doesn't work in just a minute. Okay. Gold 1 oxide. So I'm telling you the charge of gold is 1. And I'm also telling you that the charge of oxygen is 2-. So when I cross my charges, I get AU2O. And that's my formula. Okay, let's work on the next one. Sodium and nitrogen. So it's going to be sodium. I'm going to leave a space in case I need to put the charge. And nitrogen becomes nitride. Remember, you need to add an IDE ending if you have just a non-metal and not a polyatomic ion. If you look at sodium on the periodic table, it is a group 1 metal. So I know its charge always, so I'm not going to include the charge when I'm writing its name. Okay, let's move on to the next one. Copper and sulfate. So copper, I'm told here, has a 1+ charge. Sulfate, I know, has a 2- charge. So when I cross my charges, this is going to be Cu2SO4. Okay, let's work on the next one. CaClO2. So this is going to be calcium. ClO is one of my polyatomic ions, and it is actually hypochlorite. I need to look at my periodic table and determine if I need to write the charge of calcium. So calcium is a group 2 metal. It's an alkaline earth metal, so its charge will always be 2. So I do not need to include its charge as a Roman numeral. Okay? Magnesium bicarbonate. So magnesium, I know, has a +2 charge. Bicarbonate is HCO3, also called hydrogen carbonate. and its charge is 1 minus. So when I cross my charges, this is going to become magnesium. And then I have 2 bicarbonate. So I need bicarbonate in parentheses. And then I'm going to put a subscript 2 there. Okay. Number 9, iron and iodide. So I'm going to just write iron iodide to begin with, because this was iodine, and now it becomes iodide because it's the nonmetal. If I look at my periodic table, iron is a transition metal, so I do not know its charge. So I need to figure that out. So I know that iodine, or iodide as an ion, has a 1 minus charge because it's a halogen. I have 2 of them, so that's going to be an overall charge of 2 minus, which means iron needs to have a 2 plus charge in order to cancel out that 2 minus charge. So this is going to be iron 2 iodide. Okay. The next one, lead-3 acetate. So lead, I'm going to start writing down here. Lead has a 3 plus charge. Acetate, the formula for it is C2H3O2, and its charge is 1 minus. And so what that allows me to do, cross my charges. This is the formula for lead-3 acetate is going to be Pb. I'm going to put the acetate in parentheses, and then I'm going to have 3 of them, which is why I needed it in parentheses. And good. Tin carbonate. So I'm going to write out the name first. Tin carbonate, CO3 is one of my polyatomic ions. And if you look at the periodic table, tin is one of my transition metals. I do not know its charge. It's not group 1, group 2, group 3, silver, or zinc. And so what I need to do is I need to figure out the charge of tin. Okay? So for here, carbonate has a 2 minus charge, and I have 2 of them, which means that overall, carbonate contributes 4 minus, which means tin is going to have to contribute a 4 plus charge. So notice here, if you had just uncrossed your charges and made the 2 the charge of tin, you would have gotten this problem wrong. So just be careful. Okay? The reason why you would have gotten it wrong is tin carbonate originally was this. Okay? That's tin 4 carbonate, but remember, you need to simplify your subscript. So this would become tin SnCO3 with a subscript 2. This is tin 4 carbonate. Okay? Ammonium phosphate. I need to figure out the formula. So ammonium is NH4 with a +1 charge. Phosphate, PO4, is a 3 minus charge. So when you cross your charges, this is going to be in parentheses, because I have 3 of them, NH4, 3, and then PO4. Okay. For the next problem, I give you silver, and I'll leave a space in case I need to write the charge. And then Cr2O7 is one of your polyatomic ions. It is dichromate. Remember, silver is one of the 2 exception elements that are transition metals whose charges I know. Remember, silver is always +1 and zinc is always +2. So I will not put the charge for silver here because I know it always. It's always +1. Okay? And then for the last one, zinc phosphide. So as I just noted, zinc always has a +2 charge, which is why I didn't include it in the Roman numeral. Phosphorus was phosphide, right? Phosphide is the ion for phosphorus. Phosphorus has a 3 minus charge. So when I cross my charges, this is simply going to become Zn3P2. And that's it.